combustion of carbon, hydrogen gas, and ethanol. So this is the enthalpy of combustion of carbon, which is 399 kilojoules per mole. Enthalpy of combustion of hydrogen, 266 kilojoules per mole, and enthalpy of combustion of ethanol is equal to 1368 kilojoules per mole. By linking the heat of formation of ethanol, that is C2H5OH, to heats of combustion of its components and itself in an energy cycle, calculate the heat of formation of ethanol. So before we go to heat of formation of ethanol, we need to understand that this question is coming from the Hess's law. The Hess's law. What does this law state? According to Hess's law, the energy change for converting reactants into products is the same, regardless of the route by which the change has taken place. So we write that first. Okay, the energy change for converting reactants to products is the same regardless of the route taken. Are together? That is the Hess's law. So this question is actually an application of the Hess's law. Now, what do we want to form? We want to form ethanol. What's the formula of ethanol? This is the formula of ethanol. So we start by writing the formula of ethanol, which is C2H5OH. This is a liquid. Now, we are forming ethanol. We are starting from the product, we are moving back. Which are the constituent elements in ethanol? We have carbon. How many atoms of carbon? There are 2. So we write here 2 carbon, which is a solid, plus how many hydrogens? 5 plus 1? 6. So here it is plus 3 hydrogen, which is a gas. Okay, 3 hydrogen, that is 3 times 2 is equals to 6, which is the same as 5 plus 1, which is equals to 6. Plus now, oxygen. Oxygen is a gas, like this. How many atoms of oxygen do you see there? It's only 1. So here we are adding a half a molecule of oxygen. So that is the equation for formation of ethanol directly from the constituent elements. Now, when we burn carbon, what do we produce? We produce carbon for oxide gas. Okay? How many atoms of carbon do we burn? There are 2. So you write here 2 to balance for carbon. When you are balancing for carbon, we are affecting oxygen. So how many oxygen atoms have we produced here? 2 times 2? 4. So it means we added oxygen gas. Now these atoms are 4, 2 times 2 is 4. So it means we added 2 molecules of oxygen gas. Okay? Now, when you burn hydrogen, combustion of hydrogen, what do we produce? We produce steam or water. So this is steam being produced. How many molecules of hydrogen did we burn? There are 3. So the product here should also be 3. So when you write 3 here, it does not only affect hydrogen, but it also affects oxygen. So for oxygen, we'll say plus oxygen, like that. How many oxygen atoms? 3 times 1? 3. So here, the oxygen which is added is 3 out of 2. 3 over 2 oxygen, like that. So it is plus 3 over 2 oxygen, like that. Then you get water. Are we together? Now, when we burn ethanol, what do we produce? We produce carbon dioxide and water. So you put a plus in between there. Are you seeing that? So this is an energy cycle diagram. How many oxygen atoms are from the combustion of ethanol? 2 times 2, 4. Plus 3 times 1, 3. So 3 plus 4, 7. So here we are adding oxygen, which is a gas. So this is 7 over 2 molecules of oxygen. That is plus 7 over 2 molecules of oxygen. Are we together?